Here we're going to be learning about natural logarithms. It's just another little way that we can solve some logarithmic and exponential equations. So our learning targets is I can evaluate expressions using the natural log, and I can use the properties of logarithms to simplify natural log expressions. So we're going to use those same properties of logs that we've been using in the past. Okay, so a while ago we learned about the number e. Right, it's an irrational number that approximately is 2.71828 and continues on, that we've used for a base for some exponents. Okay, and we've been looking at some inverses. So here's my original function, y equals e to the x. It has an inverse function. That inverse function is the natural log function. And right, remember an inverse, when I graph an inverse, I can take it over the line y equals x, which this is a horrible drawing of a line, but it's about there, and it's a mirror image. It's a reflection. Okay, so here's our definition of our natural log function. If y equals e to the x, then log base e of y equals x, right? So we've just converted from exponential to log form. But instead of writing something of log base e, we write it as natural log using ln. Okay, so that's how we write it. So just like if we have a base of 10, we don't actually write log base 10, we just write log. Here, if we have base e, we don't write log base e, we use natural log, so the ln button. So here's example 1. We're going to be simplifying natural logs. So I want to take this expression, 3 natural log 6 minus natural log 8, as a single natural log. So I use my same log properties that I used for my common logs and my other logs. So first I see I have something out front here that I don't like. I want to turn that into an exponent. So it goes right there. So now that I don't have anything in front, I see since I'm subtracting here, I can go ahead and divide. And when I go ahead and do this, 6 cubed divided by 8, I get 27. So that is my natural log written in a single logarithm. So here's a couple problems that I want you to try on your own. So we use natural logs because there's they explain a lot of things in the natural world. Okay, so here we go. Here's our real world connection. A spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a certain velocity, and that velocity is 7.7 kilometers per second. The formula for the rocket's maximum velocity in kilometers per second is given right here. Negative 0.0098 t plus c natural log of r. The booster rocket fires for t seconds, there's our t, and the velocity of the exhaust is this c value. Okay, the ratio of the mass of the rocket filled with fuel to its mass without fuel is r. So that's where they're getting these different numbers. So suppose a rocket used to propel the spacecraft has a mass ratio of 25, an exhaust velocity of 2.8 kilometers per second, and a firing time of 100 seconds. Can the spacecraft attain a stable orbit? So we go ahead and we figure out what we have. So I have r is 25, c is 2.8, and t equals 100. So that's all the different values in our equation above. So I use my formula that I'm given, and I substitute those values in, and then I just go ahead and I use my calculator. And remember, I use my natural log, because that's what I'm given, and I simplify to approximately 8. So I find that the maximum velocity is greater than the 7.7 that's needed, so that yes, my spacecraft can attain a stable orbit. So here's another example of solving a natural log equation. Okay, so I'm given natural log of 3x plus 5 squared equals 4. So I can go ahead and rewrite this in exponential form, right? So I take e, so instead of taking the log of both sides, I'm going to turn it into exponential. So I go e to the natural log and e to the fourth. Well, I know if I have e to the natural log of x, that just equals x, because e and the natural log are inverses, so they can just go away. So that's what I do here, is I take both sides and I set them as exponential equations. So e to everything on the left side equals e to everything on the right side. So my natural log goes away. So I have 3x plus 5 squared equals e to the fourth. So then I can use a calculator to find what e to the fourth is, right? Now once I have that, I go ahead and I take the square root of both sides, and when I take the square root I have to have the positive and the negative, and then I can find this using a calculator, right, and set up both of my equations and solve for x. So I subtract 5 and then divide by 3 in both of these equations. And then I can just double check that both of my possibilities work. And they do, so we know we're right. So I can also use my natural logs to solve if I have this e in my exponential equation. So first thing I want to do is I want to get the term with my e all by itself. So I subtract my 2.5 from each side and I divide by 7, because now I have my e by itself, so I take the natural log of both sides, and again, just like e to the natural log went away, now the natural log of e goes away because they're inverses, and that's why I do that. So now I have 2x equals the natural log of 2.5. To get x by itself, I divide by 2, and I use my calculator to solve for x. Okay, so here's your homework for this section. It's also in your calendar, so take a look at that. And let's go look at our learning targets real quick. So our first one was I can evaluate expressions using the natural log and knowing when it is appropriate to use the natural log. And then our second one is I can use the properties of logarithms to simplify natural log expressions. So make sure that you have those properties down really well because they work for both regular logs and natural logs.